Good afternoon, everyone. Welcome to my webinar. This is Cui Xiaoqing from Lachance Group. I graduated from Swedish University of Agricultural Sciences, and my major was animal science. Just a brief introduction to myself. Let's get started. My webinar. Recently, I've been getting lots of questions about mycotoxins. So today, I'd like to talk about mycotoxins with you. I think everyone related to feed mills and poultry husbandry want to beat mycotoxins, but do you know anything about them? This is the topic of my webinar. The content of my webinar is divided into 4 parts. The first part is corn and its nutritional value. The second part is types and sources of mycotoxins. The third part is effects of mycotoxins in poultry. And the last part is fight against mycotoxins in poultry. Let's start with the first part. Corn and its nutritional value. About first of all, corn and its nutritional value when it comes to mycotoxin, it's better to talk about corn first. This is because corn is very important raw material in animal feed. So corn is also a protein that's why we call corn as the king of energy. The main use of corn in the world is for feed, accounting for 70% to 75%. And the amount of corn used in poultry feed formulation is generally about 50%. And also the protein provided by corn accounts for 1/4 of total protein in mixed feed. So corn is also a protein resource worthy of attention. So yes, this is corn. Then I'm going to talk about the nutritional properties and the feeding value of corn. First of all, corn has the highest energy availability in grains. Metabolizable energy of poultry is 3,250 kilocalories per kilogram, and corn also contains approximately 72% starch on a dry matter basis, and corn starch is nearly 100% digestible. Corn contains only 2% crude fiber and 4% fat, which is 2 times that of grains. So that's why. So this is the first nutritional properties and feeding value of corn. The second nutritional properties and feeding value of corn is low protein content. Corn protein content is low, it's around 7% to 9%, and the quality is poor because corn protein lacks of lysine, tryptophan. The content of lysine in corn is about 0.24%, and the content of tryptophan is about 0.07%. This is because most of the corn protein is thin, and its quality is lower than that of gluten. So this is why corn has low protein content. The third nutritional property of corn is high in linoleic acid. You know that linoleic acid is the most important essential fatty acid. Linoleic acid in corn reaches 2%, which is the highest content in all grain feeds. Corn alone can meet poultry 2% linoleic acid requirement. When poultry is deficient in linoleic acid, they exhibit slow growth. Feathers are disheveled and dull, falling, hence the egg production may decrease. The fourth nutritional properties of corn is that corn is important. Corn is important minerals and vitamins for animal nutrition. Corn is rich in vitamin E with an average of 20 milligram per kilogram, while vitamin D and K are deficient. Corn contains very little calcium, only about 0.02%. Phosphorus is about 0.25%, of which fitted phosphorus accounts for 50% to 60%. Some trace elements such as iron, copper, manganese, zinc, selenium, and other trace elements are also less in corn. The last nutritional properties of corn is pigment. Corn contains many pigments, mainly beta-carotene, lutein, and zeaxanthin. All of these pigments are fat soluble. The content of lutein is about 20 milligram per kilogram. The coloring of egg yolk and broiler chicken feet, skin, and beak are all related to the pigment of lutein, especially on the coloring of egg yolk. So this is the pigment of corn. Let's get into the second part. The second part is the source and types of mycotoxins. Mycotoxins are secondary metabolites produced by fungi in the plants before or after harvest. A large percentage of the agricultural production worldwide is contaminated by at least one mycotoxin. Mycotoxins are invisible, intangible, odorless, and tasteless. In moldy grain or case, it has mycotoxins, but in good grains, looks like very good grains, it may also have mycotoxins. From this picture, you can see that in the picture of left, you may, I think everyone may know that in these two pictures, there were mycotoxins here, but in these two pictures, I mean the two pictures in the right, looks like very good grains, right? But in these two pictures, it may also have mycotoxins. So that's why I just said mycotoxins are invisible sometimes. Moldy corn is the main. Then I'm talking about the sources of mycotoxins. Moldy corn is the main source of mycotoxins. When corn in the field, there are lots of passenger plants, also susceptible to infection by non-pathogenic bacteria found in nature. The main representatives are ZEN, DON, T2 toxins, and FUM. Corn is also susceptible. It's also susceptible to mycotoxins during storage. For example, it is infected by warehouses or utensils that have storage moldy grains. Poor storage conditions can also cause a large number of moths to grow. Then I'm gonna talk about what are the main mycotoxins in feed. There are more than 300 known mycotoxins. Among the most common and most closely related to animal husbandry are the 6 toxins produced by these 3 moths. I mean, these 3 moths, such as AFT, OTA, and FUM, TZA, toxin T2, and DON. The damage caused by mycotoxins is much greater. It's much greater when they are combined than when they occur individually. Then let's get into the third part. The third part, I'm going to talk about the effects of mycotoxins in poultry. The third part, no, let's get into the what types of mycotoxins mainly affect poultry. There are 4 toxins mainly affect poultry. Like I showed in the picture, you can see that AFB1, AFB2, AFJ1, AFJ2, OTA, toxin T2, FB1, FB2, FB and FB2. There are just some representatives that I know. So you just need to remember, I mean, or familiar with these types of mycotoxins. For the maximum suggested levels of the major mycotoxins in poultry from the picture, we can see that the maximum suggested levels of AFLA in poultry is 5 ppb. For layers, a little bit higher, is 10 ppb. And the maximum suggested levels of OTA in poultry is 5 ppb. I mean, for broilers, like starter, growth, finisher, and for laying hens, like layers and breeders, the maximum suggested levels is 5 ppb. And the maximum suggested levels of T2 for in poultry is 50 ppb, but for a finisher, the levels is a little bit higher. It's 100 ppb. Then the maximum suggested levels of DAS is 100 ppb, but for finisher it's also a little bit higher. It's 200 ppb. It's 200 ppb. Yes, and the maximum suggested level of FUM from this picture, you can see that it's 1,000 ppb. Compared with other mycotoxins, the maximum suggested levels of FUM is a little bit higher. And then let's see the maximum suggested levels of DON in poultry is 500 ppb, but for layers from this picture we can see that, but for layers the maximum suggested level of DON is 1,000. So yes, this picture, I just showed this picture to tell you guys the maximum suggested levels of the major toxins in poultry. Then let's stay at what stage of poultry production, mycotoxins generate most problems. And actually, mycotoxins affect all poultry species, mainly causing severe immunosuppression. Immunosuppression its action mechanism is based on enzymatic inhibition that reduces protein synthesis and consequently the immune response. Next, what are the clinical symptoms of mycotoxins of mycotoxins intoxication? Firstly, what are the symptoms of poultry if affected with AFLA, AFB1, AFB2, AFJ1, AHJ2? From here, we can see that the clinical symptoms of mycotoxins intoxication from these mycotoxins are hepatic injury, body weight reduction, loss of appetite, leg weakness, and relaxed wings. This is mainly for chicks. I mean the little chicks, and then blood clotting disorders, as well as disorders in metabolites of B vitamins and amino acids. So this is the clinical symptoms if affected with AFLA, AFB1, AFB2. I mean these mycotoxins. And then let's see the right. These symptoms are affected by OTA. The clinical symptoms are kidney damage, increased water intake, poor quality of eggshell, reduced feed intake, decreased egg production, as well as immunosuppression. So yes, these are the clinical symptoms when poultry are infected by OTA. Then let's see the clinical symptoms when poultry affected by toxin T2. The clinical symptoms are oral and cutaneous lesions, reduced egg weight, increased the number of poor quality eggshells, and as well as immunosuppression and decrease in yields. Then when poultry are affected by FUM, the clinical symptoms are reduced body weight, lower daily average weight gain, increased gathered weight, as well as increased mortality in poultry. So all of these are the clinical symptoms affected by different mycotoxins. Through the above introduction, we can see that the damage of mycotoxins to poultry is very serious. Through the above introduction, we can see that therefore, mycotoxins need to be of great concern during feed production and farming. In the first half of 2022, Lachance Research and Discovery Center tested 528 samples for mycotoxin statistics. These samples were sent by feed mills and farmers. Lachance Group has our own research and discovery center. From the chart, we can see that from the from the chart, we can see that from the chart, we can see that the 528 samples included 140 feed samples. Here, 94 colon samples. Here, 86 meal and brown samples. Here, 106 colon byproducts samples. Here, and 102 vegetable raw material samples here. So yes, there are the samples that we collected from different feed mills. This is a chart that can show the distribution of mycotoxins in feed and raw materials. From the chart, we can see that there are not only one mycotoxins in feed and raw materials. The samples with three or more mycotoxins detected accounted for 82%. The samples with one mycotoxins here, with one mycotoxins accounted for only 3%. So from this chart, we can see that the samples with three mycotoxins accounted for 57%. The samples with two toxins accounted for 15%, and the samples with with five. I'm so sorry. The samples with three toxins. The samples with the four toxins accounted for 57%. The samples with three mycotoxins accounted for 25%. The samples with two mycotoxins accounted for 18%, and the samples with one mycotoxins accounted for 3%. So this is a chart to show the distribution of mycotoxins in feed and raw materials. Let's continue. This is a chart to show the contamination levels of mycotoxins in feed, except for the low positive detection rate of T2 toxin. Here, T2 toxin, the detection rate of other three toxins was above 84%, and these three mycotoxins all exceeded the standard. You can see that. So this is the detection of T2 toxin. And then I'm going to show you this chart. This is a chart to show the contamination levels of mycotoxins in corn. From this chart, we can see that the positive detection rate of T2 here, the positive detection rate of T2 toxin in corn samples was as low as 6 here. At 6%, the detection rate of AFB1 was 43%, and the detection rates of the other two toxins were both above 96%, and these two mycotoxins all exceeded the standards. Okay, this is a small summary for the Lachance mycotoxins detection. Well, first of all, mixed contamination of mycotoxins in samples was very common, with more than 97% of samples containing 2, 3, or even 4 mycotoxins. In the first half of 2022, the positive rate of ZON in feed samples increased compared with last year. The average value of AFB1 was higher than that of the first half of last year, and the excessive rate of AFB1, ZON, and DON was higher than that of the first half of last year. ZON positive rate and over standard rate in colon samples both increased compared with last year. Then let's get into the last part. The last part is the fight against mycotoxins in poultry. I mean, how to fight against mycotoxins in poultry. Well, first of all, we need to reduce mycotoxins at the source. I mean, prevention against mycotoxins should start with the elimination or reduction of fungal growth in plants. But don't forget the storage of grains. In addition to controlling temperature and humidity using aeration, it's advisable to use fungal inhibitors and to use protection against damage caused by insects and rodents. So this is the first method that I'd like to provide with you guys. And then second, we need to enhance mycotoxins testing in feed and raw materials. I mentioned before, Lachance group provides testing service. We can help you test or detect mycotoxins in feed and raw materials, help you to know the quality of your poultry feed and raw materials. So don't hesitate to contact us. We are very happy to help you here. This is the third method. A third, we could add adsorbents to the poultry feed to fight against the mycotoxins. But adsorbents must be able to bind mycotoxins present in the contaminated feed without dissociating from them during their journey through the gastrointestinal tract of the animal, so that the mycotoxin absorbing agent complex can be eliminated through stool, thus minimizing animal exposure to mycotoxins. However, it should be noted that the adsorption of the adsorbent is selective, and the adsorption capacity is limited, and it also absorbs some nutrients such as vitamins. So the choice of composite adsorbent is effective. This is my recommendation. I mean, I recommend you guys to choose some composite adsorbent. The fourth way to fight against the mycotoxins that I'd like to recommend you guys is bioacids. I mean, we can add some bioacids to the poultry feed. This is because bile acids promote the solubility of mycotoxins in the water environment of the intestinal tract and accelerate the degradation of mycotoxins by intestinal enzymes. I want to mention a point here, which is bile acids don't directly acting on mycotoxins. But from this picture, we can see that bile acids could help to enhance the water solubility of toxins and enhance the ability of enzymes to hydrolyze toxins in animals. This is because, just like I mentioned before, bile acids have non-polar group. This property could help to enhance the water solubility of toxins, here, and enhance the ability to enzymes to hydrolyze toxins in animals. This is not what I said. I just copied this picture from an article. If you guys are interested in it, you can send us emails. I can send the articles to you guys. Okay, that's all about my topic sharing. If you guys have questions, you can just send us emails. This is our email. You can send us emails with your questions, and can also visit our website. This one. This is our website link. So you guys can visit it or send us emails with questions. Thank you for listening. This is all about my today's sharing.